Okay, so let's talk about sketching graphs with asymptotes. I'm just going to go through two examples with you, just to illustrate how to find those. Okay, using second and first derivatives. They are a little bit involved. They're long problems. If you look in your book, examples, they're each one page. Right, so we're going to have a lot of work to do within one problem, but this summarizes something you'll probably see with limits at infinity. So that's a good reminder. Can you automatically tell me what a vertical asymptote is of this? X equals 2. Okay, so as long as it doesn't give you a top value of 0, the value of 2, it gives us 8, we're good. So we know there's a vertical asymptote at 2, right? We can include that in our sketch. We're going to have to use limits at infinity to find the horizontal asymptote. Okay. So first, what have we been doing? The domain is the real numbers where x cannot equal 2, right? We just talked about that. Okay. What's the first derivative? Okay, the quotient rule is an option. Is there an easier one? L'Hopital's rule only applies to limits. Okay, quotient rule it is. Probably. It's not coming to mind for some reason. Okay, so who wants to volunteer the derivative verbally for us? Thanks, Corey.
3. Okay.
Corey.
3, and then 2x minus 4 plus c minus 3x plus 2 plus 2 all over 2x minus 4 squared.
You missed something. The derivative of the bottom. So it's top derivative, copy bottom, minus copy top derivative of the bottom over bottom squared. Josh has a little rhyme.
Low d high minus high d low over the square of what's below.
Right.
It doesn't rhyme, it's wrong. Low d high minus high d low over the square of what's below. My dad.
Low d high, so low derivative high, minus high d, or high d low, and then what's the rest of it?
Over the square of what's below.
Over the square of what's below.
Exactly,
Right.
because I used to switch the top round. If it doesn't rhyme, it doesn't work.
So if you want to use that rhyme, have at it. It's a good way. It's a good way to memorize it. Let's simplify that. 6x minus 6x is 0. Negative 12 minus 4.
Okay. Do you want to oil?
Okay. So where is f prime of x not defined?
2.
Right. Okay. So, but can we call that a critical point then?
No, it's not defined there.
Okay. Good. Not critical point because f is not defined at x equals 2. Okay. So you have to be careful. You have to be careful there. All right. So we're going to use this.
No.
Let's just talk about interval. So what do you get with f prime at 1?
Negative, negative 4. I don't think that's right. I don't know.
If you plug 1 in, you get negative 2 squared is 4. Yeah, negative 4, which is negative, right? And what do you get if you plug 3 in?
3? Oh,
This would be negative 4 again, right?
yeah.
Okay. What does this tell us?
It's
What does the first derivative negative tell us? Right. So we have decreasing.
okay, down.
Nope, that's the second derivative. See, this is why we're tomorrow focusing on that. Okay, so first derivative can tell us the slope of the tangent line, increasing or decreasing. All right?
Then we do the second derivative now?
Now let's do the second derivative.
Okay.
That's a little easier. Rewrite it as a negative exponent. You can use the power rule.
Oh, yay.
Yay is right. Okay.
I don't know how people can do it, like, underneath. I always have to take it out.
So we get 32, 2x minus 4 to the negative 3 times 2.
What? Did you use table?
Yes. So the power rule and then the derivative of the inside is 2.
Okay.
All right. So
Plug in 1 and 3 again?
again, same intervals, because that's where it's undefined, right? So now, and then test f double prime. What is f double prime going to tell us?
You have your infinity and your 2 backwards.
Oops.
You should probably put a double prime thing on your second derivative. Oh.
Good point. Some of you had very similar issues. Make sure you're labeling your second derivative, your first derivative, etc. What's f double prime at 1? So that's negative. What does that tell us about concavity? Yep. Concave down. And then f double prime at 3 is a positive, right? 8.
That's not 27 on the bottom.
Yeah, I just realized that. I was
Negative 88.
check your calculations there.
Oh, is it negative 8? Because on the bottom it would be, if you put 1 in, you get.
Yeah. Negative 2 2/3 power.
Come on, Sandy. 4.
Who's saying I?
Okay, we have just
I knew what you did.
okay. So here's what we have so far. We have the vertical asymptote, and then we have negative, negative over here, first and second derivative, and then negative, positive here. But we don't know the horizontal asymptote. How are we going to find that?
Put it in the calculator.
I heard someone say it. Yeah, limits at infinity. Right, so the limit as x approaches infinity, positive and negative, of the function. This is where L'Hopital's rule gets really fun. The limit as x approaches positive or negative infinity. If I plug infinity in, what do I get? Yeah, we get an indeterminate form. Okay, so we can use L'Hopital's rule here.
Yeah.
That's another option.
Yeah, I was going to say. 3/2?
Okay, that's a horizontal asymptote. Right there. Okay, the question is, so we know our horizontal, vertical asymptotes, increasing, decreasing behavior, our concavity. Where do we place the function?
Well, we know that if it's negative, negative, it's going to go like that.
Yeah, we know the shape.
So it could curve like that.
But is it up here? Is it down here? Is it?
It would be like this. It would be like that curve and that curve. Like one going down that way and one going like that.
Like that?
Yeah.
Okay, how'd you know that?
And I looked at the little graph that says what the shapes are.
Okay, so here's, if you don't know what it's supposed to look like, just plug 0 in for f. What's f of 0? Negative 1/2, right? If I plug it into the original, that's right here. Then I know where to place my stuff, because this will be decreasing concave down. This will be decreasing concave up. Woo! Okay, those are involved. Took me a whole page. They're not hard, you just got to do it. So, some of your issues on that quiz, staying organized, right? First derivative, like I made a mistake here, make sure you're labeling your derivatives. If you do not label a second derivative, but it's correct, they won't count it on a free response. Okay? You have to be very explicit. Stay organized with your tables. Do you have any questions? All right. To give you time to work, I'm going to forego the second one, but it's in your book. It's the same thing we just did. It's just a different problem. Okay. You have the problems written down from yesterday?
Yep.
Okay. Let me know if you have any questions today.
Yes.